At 5:23 a.m., June 6, 1944, the gray waters of the English Channel erupted in thunder. From horizon to horizon, more than 5,000 ships and landing craft advanced through the mist, each carrying men who would decide the fate of Europe. In the dim light, the sea boiled with white wakes and diesel smoke, the air thick with salt and fear. Over the roar of engines, men gripped their rifles, staring at the steel ramp before them, the thin barrier between life and death. Somewhere ahead, beyond the veil of mist, stood Hitler's Atlantic Wall, a fortress built to withstand any invasion. German officers, certain of its impregnability, prepared their defenses with calm confidence. They had seen Allied amphibious vessels in reconnaissance photos before, those odd, flat-bottomed boxes the Americans called landing craft. They'll capsize before they ever reach the shore, one German engineer scoffed in 1943. But as the first gray silhouettes approached the beaches of Normandy, that confidence began to tremble. The boats kept coming, hundreds, then thousands of them, moving in perfect coordination, immune to the rough surf that should have torn them apart. Each carried 30 soldiers in a vehicle, packed tight but steady, as if gliding over water too shallow for their draft. The LCVP, Landing Craft Vehicle Personnel, was an American invention that didn't belong in any German engineer's textbook. It was ugly, loud, and, according to traditional naval design, impossibly inefficient. Yet it was about to tear open the most fortified coastline in the world. For months, the Germans had trusted the logic of conventional shipbuilding. Their naval engineers prized speed, sleekness, and steel armor. They mocked the American tendency to build floating sheds of plywood and steel plate. They dismissed the notion that such crude machines could survive waves, gunfire, and weight. On the French coast, their defensive doctrine revolved around one assumption, that the sea itself would destroy any enemy landing before it reached the sand. But the sea that morning betrayed them. The LCVP slammed into the surf. Steel ramps dropped, and an avalanche of men poured onto the beaches. Utah, Omaha, Gold, Juneau, Sword. German machine gun nests opened fire, siding to the first waves. The air filled with the scream of bullets and the metallic clang of ricochets. Yet the craft behind them didn't stop. They came in endless lines, disgorging tanks, jeeps, and supplies faster than German coastal observer could believe. From concrete bunkers, officers shouted into field telephones, reporting new types of landing vessels, highly maneuverable, impossible to destroy before unloading. What had once been an object of mockery now became a nightmare. 2 years earlier, across the Atlantic, a boat builder from Louisiana named Andrew Higgins had ignored the ridicule of traditional naval architects. His company, Higgins Industries, had started by building shallow draft boats for swamp operations. The U.S. Navy and Marine Corps, desperate for a craft that could carry heavy loads directly onto shore, tested his design. It wasn't elegant. It was brutally functional. A flat bottom for shallow water, a steel ramp for instant unloading, plywood sides reinforced with armor. Higgins called the boat that could do anything. General Eisenhower later called him the man who won the war. In 1943, over 20,000 Higgins boats were ordered, mass-produced in assembly lines that ran day and night across New Orleans. The Germans, meanwhile, continued building U-boats and destroyers, sleek vessels for open-sea combat, not for the tidal shallows of Normandy. At German Naval Command headquarters, reports from occupied France grew increasingly strange. Observers noted fleets of box-like craft capable of crossing the channel without capsizing. One skeptical engineer dismissed the reports as exaggeration, claiming such boats would split open in the first strong tide. But American engineers had already solved that problem. The hull's shape and reinforced bow distributed stress evenly across waves. The ramp mechanism, powered by hand or motor, could drop in seconds, allowing troops to storm the beach before defenders could reload. In combat terms, this meant seconds gained, seconds that saved lives and cracked the German defense rhythm. By dawn, Allied landing waves followed one after another in machine-like rhythm. German artillery commanders, stunned, found their calculations useless. Their guns, fixed on narrow kill zones, couldn't fire fast enough to stem the tide. On Omaha Beach, where the slaughter was worse, the landing craft became both shield and lifeline. Many were shredded by shell fire, yet more arrived behind them, using the wrecks as cover. To the defenders on the bluffs, it seemed as if the sea itself was birthing machines. The rhythm of the Higgins boats, approach, unload, reverse, return, turned chaos into order. It was the mechanics of invasion, executed with industrial precision. Behind the lines, German General Erich Marx had predicted that any invasion attempt would fail within 24 hours. His plan depended on breaking the assault before the Allies could establish supply lines. But the unbroken arrival of LCVPs and larger landing ships shattered that timeline. Within hours, bulldozers, fuel trucks, and field hospitals were rolling onto French soil. Every vehicle that touched the beach arrived courtesy of those ridiculous American landing craft. The Atlantic Wall, designed to be a static fortress, had no answer to this dynamic onslaught. Farther inland, German radio intercept units listened in disbelief as British and American signals traffic multiplied. They could not understand how so many men and vehicles had crossed so fast. Coastal engineers sent panic messages to Berlin. Enemy landing craft, hundreds, unharmed by tides. Reinforcements arriving continuously. To them, it defied the logic of engineering and physics. They didn't know the secret lay not in steel, but in mass production and design simplicity. Higgins boats could be built in days, repaired in hours, and operated by sailors with minimal training. The very qualities the Germans mocked, the simplicity, the cheapness, were the source of their power. By 10 a.m., the defenders of Omaha and Utah beaches were running low on ammunition. Smoke and sand filled the air, obscuring targets. Allied ships offshore rained artillery support, while fresh waves of LCVPs came in, their ramps dropping like clockwork. Soldiers who survived the first landings looked back to see more boats coming. Unstoppable, endless. For the men storming those beaches, the Higgins boat became a symbol of survival, of American industry meeting human courage head-on. In Berlin, senior engineers of the Kriegsmarine studied photographs from reconnaissance flights over Normandy. The shapes were unmistakable, flat, square, shallow boats covering every beach. A technical report noted their design defies previous marine architecture logic. Too late, they realized that their mockery had blinded them. The enemy had not built better ships. They had built the right ships. Machines meant not for prestige, but for purpose. As the tide rose and the beaches filled with men, machines, and makeshift supply dumps, one truth became clear even to the most stubborn German officer. The war had entered a new age. Victory would no longer belong to those with the biggest guns or the strongest walls, but to those who mastered movement and adaptation. The Atlantic Wall was collapsing, not from bombardment, but from the relentless rhythm of wooden ramps hitting sand. By the time night fell over Normandy, the channel was still alive with the hum of engines, ferrying wave after wave of reinforcements. The same vessels German engineers had once dismissed as crude barges had, in less than a day, overturned 4 years of fortress doctrine. And as flares burned above the beaches, an officer on the bluff whispered to his stunned crew, "They built boats faster than we built defenses." What none of them yet knew was that the true genius of these strange American craft went even deeper. Beneath their rough exteriors lay an industrial and engineering system unlike anything Germany had ever faced. And by dawn the next day, that hidden power will begin to crush the Reich from the inside out. The secret behind the Allied Armada's unstoppable tide was not hidden in steel or armor. It was hidden in simplicity, scalability, and vision. In 1938, long before the beaches of Normandy were chosen, a Louisiana boat builder named Andrew Jackson Higgins had been testing a shallow draft cargo boat in the muddy bayous of the Gulf Coast. His design, based on swamp workboats, could glide over just 18 inches of water and slide up onto a bank without grounding. U.S. Marine observers watched it with quiet fascination. They had struggled for years with how to deliver men and vehicles directly onto beaches under fire. Higgins's flat-bottomed prototype, later called a Eureka boat, seemed almost too crude to be military material, yet its performance broke every assumption in naval architecture manuals. When engineers asked Higgins about hydrodynamics, he laughed. I Build boats that work, not that look good. When war came, that philosophy became the foundation of Allied amphibious warfare. The U.S. Navy and Marine Corps adapted Higgins's design into what would be officially known as the LCVP, Landing Craft Vehicle Personnel. The specifications were brutally practical. A length of 36 feet, a beam of 10 feet 10 inches, a draft of just 3 feet, and a top speed of 12 knots powered by a 225 horsepower Gray Marine diesel engine. It could carry a 36-man platoon or a jeep and a dozen troops. The ramp, made of steel plate and lowered by a hand crank, allowed for lightning-fast disembarkation under fire. Every inch of the design was built for one purpose: to close the final 100 yards between sea and shore faster than any enemy could react. In German engineering circles, such a concept was dismissed as a joke. To their naval architects, a boat that could neither fight nor survive heavy seas was an absurdity. Their minds were tuned to the elegance of destroyers, the stealth of U-boats, the armor of E-boats. But the Americans, under Higgins's relentless drive, redefined what warships could be. A vessel didn't need to fight. It needed to deliver fighters. That shift in doctrine would rewrite amphibious warfare forever. U.S. Navy Bureau Ships Report 1943. By early 1943, Higgins Industries in New Orleans had transformed from a regional boat builder into one of America's most critical war suppliers. Its assembly lines rivaled aircraft factories in efficiency. Over 20,000 workers, men and women, black and white, skilled and unskilled, labored in 3 shifts to meet demand. Production records show that one new LCVP rolled off the line every 20 minutes. War Production Board Report 1944. Factories were retooled with conveyor systems, and naval inspectors worked side by side with welders. Higgins personally walked the floor daily, bellowing over machinery. Keep them simple, keep them fast. His creed echoed through every plank and rivet. The Germans, bound by rigid production hierarchies, could not match such flexibility. Their shipyards in Bremen, Hamburg, and Kiel were optimized for precision, not speed. Each vessel was a masterpiece, each delay a disaster. German Naval Command saw no reason to build thousands of small, unarmored landing craft. They still clung to the idea that an invasion fleet would need armored transports, escorted by cruisers. Even as Allied intelligence leaked hints of new American amphibious craft, German engineers dismissed the reports as propaganda. OKM Technical Memo, 1943. When the Allies tested Higgins boats in amphibious drills in Scotland and North Africa, reports showed stunning efficiency. At Arzew and Oran in 1942, U.S. troops landed faster and with fewer losses than any prior amphibious assault. Eisenhower's planners took note. Every minute saved on a beachhead translated into lives spared. By 1944, the LCVP had become the backbone of every invasion plan. Operation Husky, Salerno, and finally Overlord. U.S. Army After Action Summary, 1944. In the early hours of June 6, 1944, the Higgins boats proved their mettle in the bloodiest test imaginable. The German 352nd Infantry Division manned the bluffs above Omaha Beach. Equipped with MG-42S, 75mm guns, and fortified bunkers overlooking open sand. Allied naval fire had battered the defenses, but the killing zones remained intact. As the first LCVPs neared shore, German gunners opened up. Dozens were hit, some torn apart mid-sea, but hundreds more followed. Each boat that reached land dropped its ramp and released a storm of men into the chaos. Many soldiers were cut down instantly, yet others pressed forward, crawling over bodies, driven by the relentless rhythm of the invasion machine. Inside the surviving boats, engineers and coxswains worked miracles. Steering cables shredded by shrapnel were replaced mid-run. Engines flooded by seawater were hand-cranked back to life. Crewmen, often teenagers, piloted through burning surf, steering toward gaps in the smoke. The LCVP's flat hull, despised by German theorists, allowed them to beach even when half sunk. Soldiers leapt into waist-deep water, their boots sinking into the churned sand. One boat captain later recalled, "She looked like a box, but she rode the sea like a warrior." Oral history. Higgins Industries Archive, 1946. On the German side, panic began to spread through coastal command. Reports described the boats as indestructible, arriving faster than the tide recedes. Machine gun crews ran out of ammunition. Field commanders, stunned by the tempo, tried to adjust firing angles, only to find that fresh waves had already landed elsewhere. The precision of the Atlantic Wall's defense zones, calculated for slow, conventional landings, collapsed. German coastal artillery log, June 6, 1944. Meanwhile, at sea, a vast choreography unfolded. Larger LSTs, landing ship tank, released their own smaller Higgins boats, forming living arteries between sea and sand. Supply officers on destroyers tracked thousands of individual runs. The entire system depended on one principle: continuous flow. Higgins boats carried troops in, ferried wounded out, and returned for more. No design like it existed in the German arsenal. Their few amphibious vessels were either too heavy or too specialized. The LCVP, by contrast, was modular, interchangeable, reparable, endlessly repeatable. By midday, as Allied forces pushed inland, German spotters from the 716th Division reported something unprecedented. Beaches covered with landing craft, all identical, all functional. Captured German report, June 1944. Even the Luftwaffe pilots who strafed the beaches were bewildered by the scale. From the air, the boats formed geometric patterns, rows upon rows, moving in synchronized precision. One pilot radioed back, "They've built a bridge of boats." It wasn't an exaggeration. Behind every wave of soldiers was an industrial miracle. Steel and wood harnessed by a nation that had turned factories into extensions of the battlefield. Higgins Industries, alongside shipyards in Philadelphia and Brooklyn, produced over 23,000 LCVPs by war's end. Each cost less than $15,000 and took barely 2 weeks to build. The Germans, producing intricate U-boats at a fraction of that rate, could only watch as the Allies converted mass production into tactical dominance. U.S. Strategic Bombing Survey, 1946. As the afternoon sun glared over Normandy, the pattern of invasion shifted. Armored bulldozers, landed by LCT's larger cousins of the Higgins boats, began clearing obstacles, while engineers set up pontoon causeways. The sea lanes were now highways, guided by the ceaseless work of thousands of coxswains navigating tides and smoke. German coastal defenses, designed to channel enemies into narrow kill zones, were overwhelmed by sheer numbers and unpredictability. Every ramp that slammed down brought more men, more machines, more momentum. Inside the command bunkers at Cannon Bayou, German engineers pored over field reports. They realized too late that the Allied boats' flat hulls distributed load evenly enough to survive direct artillery shock waves. Their own high-velocity shells often ricocheted or passed clean through without detonation. Kriegsmarine Technical Evaluation, 1944. This was no accident. The U.S. Navy's Bureau of Ships had refined hull geometry to reduce pressure points and spread kinetic force, a design principle learned from barge construction, not warships. By nightfall, the defenders' disbelief had turned to resignation. The Atlantic Wall had been built to resist strength. It had not been built to resist adaptability. As German commanders radioed for reserves that would never arrive, Allied convoys kept landing uninterrupted. What the Germans had mocked as primitive had, in practice, become unstoppable. And deep within that industrial rhythm lay a truth they had never imagined. The Americans had not only built better boats, they had built a better way to fight wars. But in the months that followed, the legacy of those flat-bottomed craft would stretch far beyond Normandy. The same principles that carried men across surf would carry entire armies across rivers, harbors, and continents, turning the tide of the war itself. By late summer 1944, the echoes of Higgins' boats still lingered across the channel. Normandy's beaches, once choked with wreckage and bodies, had transformed into sprawling harbors, artificial cities of steel, fuel drums, cranes, and endless lines of vehicles. It was a living organism, fed day and night by the same flat-bottomed craft that German engineers once laughed at. Every gallon of fuel, every ration box, every tank track that reached the front line came ashore on a Higgins boat. The invasion had turned not just on courage, but on logistics, the ability to deliver war faster than the enemy could resist it. U.S. Army Transportation Corps Report, 1944. By July, more than 1 million Allied soldiers had landed in France. The Germans were stunned not by the initial assault, but by its unrelenting sustainment. Every attempt to bomb supply lines failed to halt the flow. American and British engineers built Rhino ferries, modified Higgins boats with steel pontoons that extended makeshift docks out to sea. Within days, Mulberry harbors rose like industrial fortresses off the coast, allowing LCVPs to unload directly into floating depots. The Germans' dream of bottling the invasion at the beaches evaporated. A coastal colonel wrote bitterly in his diary that the enemy does not conquer the land. He manufactures it beneath our eyes. Bundesarchiv, officer diary. The psychological toll on the defenders was immense. German soldiers had been trained to expect waves of men, not waves of machines. They had faith in the Atlantic Wall's geometry, minefields, concrete teeth, anti-tank ditches, all rendered obsolete by the tempo of Allied resupply. On the beaches of Omaha, bulldozers flattened barriers faster than they could be rebuilt. Where artillery destroyed a causeway, engineers replaced it. Overnight, the war of attrition the Germans prepared for had turned into a war of motion, powered by the most underestimated craft of the war. Inside captured German command bunkers, Allied intelligence officers found technical analyses of the Higgins boats. The documents revealed disbelief. Construction, unrefined. Seaworthiness, low. Tactical effect, extraordinary. Captured Engineering Report, 1944. They couldn't comprehend how such crude-looking machines could achieve strategic victory. Yet that paradox was precisely the key. Higgins's design eliminated the complexity that slowed German production. Where German engineers prized precision tolerances, the Americans favored interchangeability. A damaged ramp on one boat could be replaced with a part from another. Welds didn't have to be perfect, just fast. The United States had weaponized the factory itself. That doctrine of industrial warfare left a psychological scar on Germany's officer corps. In post-war interrogations, many cited the endless material strength of the Allies as their greatest shock. But behind that strength was design philosophy, an understanding that wars are won by what can be built, not merely what can be imagined. U.S. Strategic Bombing Survey, 1946, German engineers had designed for superiority. Higgins had designed for sufficiency. The result was that the Allies could lose hundreds of craft in a single day and replace them within weeks. Among Allied troops, the Higgins boat became a symbol of reliability. Soldiers joked that it was the box that beat the boxcars, a nod to its ability to deliver more material across open surf than any rail line could. To many veterans, its memory was visceral. The clatter of the ramp, the smell of diesel and seawater, the sound of bullets striking its steel plates. Those sensations stayed with them long after the war ended. When Eisenhower toured liberated France in August 1944, he told reporters, "Andrew Higgins is the man who won the war for us." It wasn't flattery. It was recognition that industrial ingenuity had achieved what no weapon alone could. As the Allied advance swept across Europe, the same design philosophy multiplied. Rivers like the Seine and Rhine, once natural barriers, became temporary seaways. Army engineers modified Higgins boats into assault craft, bridging equipment, even floating hospitals. In the Pacific, the same hulls that carried men onto Normandy's beaches now rode waves toward Saipan, Iwo Jima, and Okinawa. Marines gave them nicknames: Higgies, Ramps, Jesus boats. They had become part of the language of war. U.S. Marine Corps Field History, 1945. German officers captured in 1945 still spoke with disbelief. One interrogated naval engineer admitted that, had they possessed an equivalent fleet of small craft, perhaps the Channel would have remained uncrossed. Yet by then, the lesson had spread far beyond Europe. Amphibious doctrine across the world had changed forever. Future armies would learn that victory demanded not only courage at the front, but foresight at the workshop. The landing craft, small, ungainly, and endlessly replicable, had redefined the scale of modern war. The psychological divide between the two sides was stark. In Germany, The engineer was seen as a craftsman serving the state's ideology of perfection. In America, he was a problem solver serving utility. Higgins himself, a fiery Irish American with no patience for bureaucracy, embodied that ethos. When naval committees hesitated to approve his prototype, he famously barged into Washington offices, dropped model boats on the tables, and said, "Try to stop this one from landing." His defiance mirrored the nation's industrial will, that spirit of improvisation, tinkering, adapting, ignoring convention, had built a fleet that could defy logic. Higgins' oral memoir, 1946. After the war, those same principles became the foundation of Cold War logistics. The U.S. Navy's amphibious doctrine evolved into a global strategy of mobility, rapid deployment, pre-positioned forces, modular supply systems. The lineage of the Higgins boat extended into the Landing Craft Utility, LCU, and the air-cushioned LCAC, which could skim across surf at 40 knots. Engineers at General Dynamics and Boeing credited the Higgins principle for influencing everything from assault hovercraft to modular bridge design. The lesson was immortalized in training manuals, designed for the mission, not the museum. Navy Amphibious Warfare Doctrine, 1952. Even decades later, in conflicts like the Gulf War and humanitarian operations in Southeast Asia, the DNA of the Higgins boat endured. Modern landing craft, cargo modules, and amphibious assault ships all trace their lineage to that 36-foot plywood box that once cut through the surf of Normandy. The industrial logic that Germany mocked became the foundation of post-war military dominance. When war planners in the 1980s analyzed amphibious strategy, one footnote appeared again and again. The principles of Higgins remain relevant. But beyond tactics and machinery, the legacy of the Higgins boat lay in its humanity. Every man who rowed one onto the shore, every engineer who built one in the New Orleans heat, was part of a quiet revolution, the democratization of war-making. No longer was technology reserved for the elite. Now, the ingenuity of a single boat builder could shape empires. The German engineers who once scorned had designed for prestige. The Americans had designed for a purpose, and in that difference lay the future of warfare itself. As the tide rolled back over Normandy that night in June 1944, the wrecks of hundreds of Higgins boats lay scattered along the sand, some burned, some shattered, others half buried. Yet from their splintered hulls rose an army that would free a continent. Their steel ramps had become bridges not only from sea to land, but from old world to new, from perfection to pragmatism, from arrogance to adaptability. The Atlantic Wall was supposed to be eternal. It lasted one morning, and it was undone not by battleships or bombers, but by the hum of small engines, the rhythm of wood against surf, and the stubborn genius of a man who believed that simple things, built well and built many, could change the world. In modern war, connection outweighs firepower, and speed defeats armor. The Higgins boat proved both, and in doing so, redefined what it meant to conquer the impossible.